Hello, in this chapter we will learn about the risk solver platform, which is called as the RSP. So this is an example for a product mix. We have different inputs for labor, raw material, unit price, variable cost and unit profit cost for 6 different products, and we have the constraints for labor and raw material here. These are the decision variables, the 6 product types and the demands. We have the formula here for the labor used, which is the sum product of the PM decision variables, which are these. The decision variables are named as PM decision variables, and the PM labor, which is this. Similarly, for raw materials used, we have used the formula is equal to sum product PM decision variables and PM raw material, which is this range here, the PM raw material. And for the objective function, we have used a function sum product, and it is used for PM unit profit into the decision variables. Now we will learn how to use the risk solver platform in this case. So we will click on risk solver platform here. So we get this task pane. Now we will add these decision variables. We will select this, go in decisions and click on decisions here. So you see this is added under variables, decision variables. Now you will click on the 0.00, which is under the objective function profit. You will click on it and go in objective. So this cell has already been set, and we want to find the profit which is maximum for normal, and you click OK. So this is added to the objective function, which is maximum. Now you add the constraints. You click on constraints. Now you will select these C18 to C19, which is less than equal to E18 to E19. We will go for normal and we will say add, since we have another constraint here. So we will add another constraint for the decision. We have added the constraint for the decision variables, which is less than the constraint for the demands. This will be normal, and you click OK. So you see the constraint for the demand is under the bound, and the other labor used and raw material used constraints are under normal. You can see the objective is selected here and the decision variables are here as well. You can check if the objective is linear. So you select this cell C22, you go under decisions and click on plot. So it shows you that the objective function is linear. After doing this, we can go in the platform for the task pane, and you can see various optimization model, simulation model here. You can check if these are suitable for yours. So these are fine here. Go in engine, you will select here standard LP quadratic engine. You select it. You can change this assume non-negative to true. This is where your output will be. So now that we have done everything, we will go on optimize under solve action, click on it. This gives us a value, which is the profit as $6,625, and it shows us that product 4 and product 5 will have an amount, whereas the others will be 0. We can find the reports for these by going under analysis reports. You can go for optimization. You can click on the answer report. So this gives you an answer report here, where it shows which constraints are binding and which are not binding. You can go back to it. You can go for another report, which is the sensitivity report. So this will give you the reduced cost and the shadow price, etc. You can go back and find another report, which is the limits report. This report also gives you an overview of all the values. So these are the 3 reports that you can find. There are also many other reports once you go under the reports section. Now to find for the infeasible, what we will do is we will go in model again, and to find if this is infeasible, we can change this bound constraint to greater than equal to. Now we will go and optimize and click on it. There's a value of $17,397.8. So it shows here that the solver could not find a feasible solution. Why is that? Because the amount produced here for product 6 shows as negative. So we can go in reports and we can see a feasibility report here. So it shows that this condition is violated because it's negative. Now to find for the unbounded condition, what we can do is we can uncheck this bound constraint and we can change this objective to minimize. We can change this assume non-negative to false, since we want the decision variables to be as low as possible to make it unbounded. So we've changed this to false. Now we can go on optimize, and it shows here that the objective values do not converge.